Ladies and gentlemen, good evening. Thank you for joining our Online Science Café session. The KITION Planetarium Observatory organizes at the last Tuesday of every month a Science Café. Tonight we have with us a great speaker that was introduced to us by our friend and colleague, Dr. Xenophobe. The speaker is Dr. Raul Perez-Enriquez, all the way from Mexico. And we are happy to see him with us tonight, sharing his knowledge with us. Tonight's Online Science Café's subject is title is The Gnomon and Solstice Shadows, a Universal Paradigm. And Dr. Raul is from as I mentioned earlier, is from Mexico, from the University of Sonora, and he obtained his doctorate at the University of Sonora in 2007. His bachelor degree was studied as Faculty of Sciences, Universidad Nacional Autónoma de Mexico, 1975. He worked as a nuclear researcher during almost 10 years at INIM. Also, he made research in the field of energy generation by alternate source in CITION. He became lecturer at the University of Sonora in 1986. Since 1996, he was full-time professor at the Department of Physics at UNISON. Today, he's a jubilated researcher. In July 2008, Telesio Galilei Association awarded him with the gold medal in hadronic chemistry. The medal was granted for his contribution to hadronic sciences, mainly for his work on exact solution to the three-body model of the hydrogen included in his doctoral thesis. He was also awarded by another association in Greece for his contribution to science in the year 2015. Between his papers in the fields of computer-controlled instrumentation and history of metrology, there are the design and construction of a talking metronome and a multichronometer with an RS-232 interface. In the latter, he has presented his work in the national and international meetings, mainly about the units of length of Stonehenge, and its relation with the origins of the English systems of units. Recently, he published books related to archaeoastronomy. Physical and paradigmatic issues of the Gnomonic Factor and interpretation of the Zhou Bi Suan Jing, a Chinese and holistic cosmovision of the world. Both are in Spanish, and we are looking forward either to learn Spanish or translate it to English. Computer control experiments and his passion on Mobius strip gave him the way to make an evaluation model of the high critical temperature superconductors. About this, it is worth to mention his article entitled "A Structural Parameter for High TC Superconductivity from Octahedral Mobius strip in RPA-CU 0123 type perovskites, published in 2002 in Revista Mexicana de Física in English. Dr. Perez-Enriquez, has 7 committed with diffusion and divulgation of science and technology. A few years ago, he developed the Talleres de Ciencia Infantil, if I say it correct in Spanish, and conferences and talks in the frames of Veranos de la Investigación para Bachilleres, correct?
Bachilleres.
Bachilleres. In the field of
bachelors,
okay. In the field of the divulgation, University of Sonora published him in 2012 a bilingual book entitled Adventures of the Tachyon Through Space-Time, and in 2005, Como Piedrecilas en el Estanque, correct? Okay, so my Spanish are getting better after the episode. Raul. So,
thank you very much, George, for this presentation.
It's a great honor to have you here, and we are all ears, as we say in Greece and Cyprus, to hear what you have to say. Yes, thank you for doing for us a great honor. Thank you very much for this presentation.
Thank you very much, all of you, of the presence here in this presentation. I'm going to share my screen in order to have the presentation ready. As Professor Trilla says, this is the theme, the Gnomon and its Solstice sciences, shadows, a universal paradigm. This aspect is presented because I have published a book that I dedicated to my granddaughter Yailem and Valeria, and to my grandson Alejandro. And also I dedicated it to the green overcoat that was lost on the way, but accompanied me in the most significant moment. You will, I hope you will understand this presentation when I talk about precisely of Stonehenge. That is one part of the book. The book, the objective of the book has several aspects: physical, like nature of the light, fundamentals of the apparent motion of the sun, the horizon system, solar simulation, and behavior of the Mnemonic Factor, and also aspects as paradigmatic cultures to be considered, findings of the Mnemonic Factors in several places of the world, in several cultures, and the mnemonic paradigms that can be developed from them. At the end is an epilogue, but this content is I want to emphasize that the orientation of the talk is to give you, to convince you that these solstices, shadows of a gnomon, are present in different parts of the world at different times in the eras, and that it may be present to have been the foundations of mathematics. This is the objective of my talk. That's why I'm going to share some experiences here that are oriented to that find. I must say that this begins in Stonehenge. All this process of evaluation of this knowledge begin when I visit this marvelous place in England, that it is called Stonehenge Monument, and it was almost 20 years ago that this visit take place. When I saw this monument, I saw this part of the monument here, and from this great skeleton here, I hope you can find it in the picture, and this stone here that is half the height of the southern circle, all begins with that point. Then we have to talk about mnemonics, sundials, and gnomon, and we have to share that these cultures have been established since the man straight upright in its evolution. The evolution as proposed by Rubén Calvino, that is with him today, this will be, he mentions that that since the beginning of the man, kind, we can have a gnomon because the vertical position of the human body projects a shadow, and this shadow tells much about the space around the people and to the time it transcurs in the time. This space can be seen as how the shadow changes along the day, from a very long shadow in the morning to a very long shadow in the afternoon. But at the middle of the day, there is a smallest shadow in the day, the midday shadow. And also, if we see this shadow changing from one day to the other, and we have the origin of seasons, the change of the length of the smallest shadow in the day. Then the human could be stand up as a gnomon, as I show here in this picture. This is from aborigines in Kenya that at the beginning of the 20th century already has the tools for measuring the shadow and know what time or what season is in that moment. Then this is part of the knowledge that we have to know. The gnomon, I can say, it's present along the evolution of man, and it gives a key to understand this knowledge. The main issue that we have to convince is that the triangle could have its origins. The concept of triangle could have its origins in the gnomon and the mnemonic triangle, that it is formed by the gnomon, the shadow, and the sun rays that produce the shadow. In this concept, you have a triangle that could be the beginning of the computation of the not computation but calculation of shadows, like that the history says that Tales del Mileto, Tales of Miletus, uses to know the height of the Great pyramids in Egypt. With this approach, we can know the height of a pyramid, for example, looking at the shadow both made when the sun is at 45 degrees. In this case, the height is exactly the shadow, and in this way we can have this calculation. Then the mnemonic triangle could be the best, the beginning of the mathematical concept of triangle, and it has a meaning for that. The other aspect that we have is, for example, the Vitruvius way of identifying the situation of each city. Vitruvius, in the 10 books of architecture, tells that it is necessary to put a bronze staff or a bronze gnomon in the center of the city in order to know the time and in order to know the seasons. This part of the argumentation has its meaning, and I will talk of this again about the Vitruvius and how they mark the shadows in this part. But for now, let me say you that we are talking about two very special shadows that are along the year. The longest one, when the rays of the sun in the winter solstice goes to the Gnomon and then produces a very long shadow, and the other is when the sun is more in a high position. In the summer, the shadow is shorter. And from this concept, it was precisely in Stonehenge where I deduced that this difference of shadows over the Gnomon makes a factor that I call the factor F, and also Rubén Calvino suggested the Mnemonic Factor name, and then we use it today, the Mnemonic Factor. This factor, in the case of Stonehenge, takes a value of 3, and this was the how you say the turning point, the detonation point of this presentation, this concept, because as we are going to see, it has a relation with the structure of Stonehenge. Then we can say that this is a single, the Mnemonic Factor is the solstice in winter shadow minus the summer solstice shadow over the Gnomon. This has no units, and all depends in the latitude of the site where we are studying this. And also a very important thing is that this value also depends on the obliquity of the ecliptic that gives us a sense of time, a time passing through the years. This Mnemonic Factor has these two fundamental variables: the latitude and the obliquity of ecliptic. Here is the definition. It is applied for all the places, but if you can change, you can change also some of these variables. For example, instead of summer solstice shadow, we can have the shadow for the day when the sun is at 45 degrees. This will be a number 1, because it's the Gnomon times the Gnomon is 1, because the shadow is the same as the Gnomon, and we can have the Platonic Gnomonic Factor that will appear here in the talk several times ahead. Okay, well, this is the definition, and we are then talking about two special shadows: the summer solstice and the winter solstice shadows. This is the summer solstice, and this is the winter solstice shadows. I will take the example of Alexandria. Why Alexandria? Because I have to take a trip to the epoch of around 250 years before Christ, where some elements of the use of these shadows appears in the literature. It is the case of the Stonehenge, of the Eratosthenes obliquity of the ecliptic measurement, that the history says that he measures the obliquity of the ecliptic. But how he measured this obliquity of the ecliptic? The way I suggest is that knowing these shadows, we can draw in the soil the gnomon and the shadow and the shadow of the solstice, and put the circle, and we can measure from G to E with a compass or with a transportator, or with an arc, not an arc, a course that is coming from here to here, and with a repeated value of this to here, and then to here, and then to here, we can have this. In this case, for the first circle, it takes 7 times the course, but we not complete the 360 degrees. Then if we go again for the second time, we have here that in the first time were 7 times, and this gives the angle covered, and in the next time we can put 8 chords to have 15, and then 7 to have 22, going that way until on the end of the 11th turn, we have 83 that makes the 360 degrees flat. This means that the angle is 360 degrees, and then we can say that the angle to be measured is exactly 47.71 degrees. That is the length of this arc. Is the degrees of this angle, and the half part is the obliquity of the ecliptic. Then the obliquity of the ecliptic is 1/83 times 360 degrees. That means this 47.71 degrees, or 23 degrees, 51 minutes and 19 seconds. That is the number attributed to Eratosthenes. The other part that we can look at in this analysis of solstices shadows is the other one, the other one of the measures that are attributed to Eratosthenes, the circumference of the Earth. In this case, we have both shadows, but in this case, we are going to take only the summer solstice shadow. And in this case, for Alexandria, we have that a gnomon of 80 units gives a shadow of 10 units. Then we can construct a triangle, making this triangle with 8 knots and 1 knot here, and then to complete, to make a square triangle. The history says that he measured the angle to be 7 degrees and 12 seconds, or 50th of a circle, but it's more difficult to measure this angle in such way. But using this triangle I made, this triangle here, that is 8 units and 1 unit, and then to recover this, we can put one triangle adjacent to another, another, and another, and we can have 50 and a small piece that makes the half. In that way, we can have that the times of the 8th shadow of the circumference is 50.5 times. And if we consider an Alexandria to Siena distance of 5,000 stadia, we can find that the circumference could be given as a 252,500 stadia. That it is, if we consider a stadium of 160 meters, that is a value known as the one of the measures used in ancient Greece. We can have an approximation with a 1% of the estimation of the circumference of the Earth. This could be done that way by Eratosthenes and could have been used. Then in this case, we are using both shadows, both important shadows by Eratosthenes. Vitruvius, as I said, also make this diagram, elaborated diagram, to explain what he calls an alemma, that is representing here the shadows, and it is established that it is 24 the obliquity of the ecliptic. This means it's an era that is just before Vitruvius. This notion came before Vitruvius, and he puts this data in this diagram. Then again, the two shadows, the two important shadows, are here. Also in this diagram, the shadow of the equinox is known here in this point C, and we have already this this diagram are very useful for the calculations on all the recommendations Vitruvius introduces in his 10 books of architecture. We have here, then we are going to have another analysis of, this is the, as I say, the literature that is in writing. We read some of ancient books or references to ancient authors that have written about the Gnomon in this way and the shadows. But there is also another type of knowledge that could be found without being written explicitly, but could be deduced from the facts that are represented. In this case, we are talking about 3 examples, and well, the last one is going to be also written, but the Stonehenge example and the Erolotos Oracles examples are not written that way, but it can be deduced. And the Zhou Bi Suan Jing is also written, but is an ancient information coming from the past. This is the way. Then I'm going to go to the examples here, remembering that all the things I have already said about Stonehenge. As I mentioned to you, Stonehenge and its surroundings are very interesting place. We can walk the monument. I have been there. I have the pleasure to have been there inside the places where the rocks are. It is difficult, but I managed to go there, and this was very long time after I saw this structure. Here, as the Great Trileton, this one, the height of this trileton is around 7 meters and 32 centimeters, and this stone 11 is around 2 meters and 44 centimeters. Then from these two, we can find, let me say that this Stonehenge is in England, and it is a pathway from London and goes to the west, and in the latitude of 51 degrees and 10 minutes, and the longitude of only 1 degree 49 minutes. These two data and the date of construction of phase 3 around 2000 and 2000 BC are useful, because using both methods, I can have the shadow of the structure, and I can have this. This is the arrangement of the ideal design of the Stonehenge. This is the Sarsen circle of a Stonehenge. This is stone 11. Here, pointing exactly to the south, as this line mentions. And these are 5 triletons. These are 5 triletons, and the heights of the triletons, and this is the altar stone. The heights of the triletons are can be measured significantly, and we can have the structure. The Great Trileton would rise up to 7.3. That means 3 times the stone 11. And then I have to recall you that I have measured for Stonehenge, the mnemonic factor was 3. This is the point where the concept of mnemonic factor, that is the shadows of the solstice, shadows of the gnomon, becomes connected with the structure of the Stonehenge monument. The altar stone is 5, and it's almost twice. The Sarsen circle is also twice the height. This means that the stone 11, this one, is halfway of the height of the Sarsen circle, that it is supposed to be all around the same height, except in this part where this lower height is found. Then we have, in this case, we have, if we put the latitude and the obliquity of the ecliptic, we can have the shadows and have the mnemonic factor more directly. It's exactly 3 1/4. That is, is the value. Then this is, I'm going to return to this part in showing that this has a meaning with the heights of the other 3 litons. This is the Stonehenge monument and the way it behaves in the part of this part. The second example I want to mention is Erolotos Oracles, mainly the Erolotos Oracle at Dodona. Dodona is one of the oracles mentioned by Herodotus in his history, and in the book 2 of the history of Herodotus. Let me say you what is the text in the book. The following tale is commonly told in Egypt about the oracle of Dodona in Greece and the temple of Ammon in Libya, Egypt. They say, the priests, that 2 sacred women were once taken from Thebes by the Phoenicians, and the history says that the one of them was sold in Libya and the other in Greece, and that these women were the first founders of the oracles in these 2 countries. We are saying that this part is that 2 oracles are related with women coming from Thebes, and a very interesting place. But this cannot mean anything unless I tell you the big history, the big the big picture of this part is that I was not working Herodotus Oracles. I was working using my Mnemonic Factor, Platonic Mnemonic Factor. I asked with the help of Xenophon Musas, that is here with us today also. Thank you. We have asked where the Platonic triangle appears in the shadows of the solstice, winter solstice, and the day when the Gnomon is the shadow of the Gnomon is the same of the Gnomon. Where is the place in the world to look at for? Then this means that if we take the mnemonic factor, the Platonic mnemonic factor, and take the mnemonic factor, we can have the obliquity, here must be theta. Theta is the tangent of 2. This means that the latitude of the place must be 39.54 degrees. And that's the way I found. I look at the map and search for a place interesting in Greece and found Ioannina. Ioannina was the place I found initially, but when I saw that Ioannina comes from the Byzantine epoch, I tried to be more in the past, an earlier place in the past. And then I found that near Ioannina is the place of Dodona. Then the exact value of the triangle could be, if we use Dodona and the obliquity of the ecliptic for the 23.89 degrees, that means around 1700 BC, we found this. We found that this is the place, and then I look at, well, what is Dodona, and then I came at the end with the oracles. But there is more. There is more. Results that the Temple of Ammon in Libya is located in the Siwa oasis that is in Africa. It's in Libya, but earlier was Egypt. And the triangle is formed, is the 3-4-5 triangle, the Pythagorean triangle. That this means that the Platonic Gnomonic factor is 1/3. Again, this is an important thing that I will come back again soon. But we have these two places, the two oracles. Then we can say that the priests or the sacred woman were looking for places where the shadows of the gnomon make such triangles coming from Egypt. It's an interesting hypothesis to work it down. The other example I have to mention is the college Zhou Bi Suan Jing and the solstice shadows, because in this case, in the Far East, in the case of China, there are explicit mentions in this book of the mnemonic, the two gnomon shadows at solstices. One of the they appear as a measurement of shadows of a gnomon of a height of 8 chi, 8 units, say 8 units, no matter what is the size, 8 units, 8 chi, and gives a 30.5 chi for the winter solstice and 1.6 chi for the summer solstice. This assured in the picture is the shadow, is the difference of shadows. And with this information, with these two shadows, they elaborate whole the world, whole the construction of the China vision of that time, or an epoch before that. Before that time, this was, I must say that this was compiled around the year 100 BC, but the information of these shadows indicate me a place that is at 35 degrees north, and using the Lascar approximation, 2900 BC is the epoch of this information. Then it seems that these shadows come from the past and was compiled in a series of documents telling this. And this book is really a cosmovision, as I will talk again to this part. As you can see, the different things I have mentioned already gives you the idea that the summer solstice shadow, the winter solstice shadow of a gnomon, has an intervention, an important intervention in several cultures around the world. I cannot have time to go to details as I do with these two examples, But in the book, I explain I go ahead with these explanations, and I present, for example, the discussion about how the people can imagine that the light rays go straight forward. Is, for example, in this evening is afternoon sun through the clouds, that the rays come very straight. Or in the other parts in the literature that you can find the ways how to find the north and the south and the west and the east. If you wait for the morning sun and have the shadow and take a circle around and wait for the afternoon shadow where the circle goes again, the shadow cuts again the circle, we have this thing at the middle. You can have the way to identify north and south. And east to west is the directions of this. Also, we can find the discussion about how to measure with the shadows of elements that are not very thin or thick. Well, the diffraction uses with a tool like this, that is seen here, can put a very fine in order to measure an exact, and this comes from Eisler, that has studied the Egypt evolution of measurements of the shadows. And also there is another example that comes, the Susa tablet. The Susa tablet, it's the one that has these measurements, 30, 40, and 50. That is the 3, 4, 5. But the important point here is that this in this case, if it is produced by a gnomon, we have that the gnomon will be 40. Then we have 30, 40, and 50, the measurements of this part. This is the way it looks like. Also, in the physical aspects, sorry for this title, the physical aspects of the gnomon also comes that no matter if you are in a Earth-centered world, like in the past, the sun makes its round around and gives also the shadows of the solstices with the obliquity of the ecliptic. Or you can have the sun in the center of the world in a Copernican picture, and we can have this obliquity also seen in the Earth around the sun with the shadows produced in the different times. Then, no matter what is the system you are working, the same features for the solstice shadows are found in these two ways. Let me explain that we also talk in the book about the horizon and the shadows. We talk about the obliquity of the ecliptic, the seasons, and more importantly, we can say that we have here a planisphere indicating a very interesting thing. I put in colors the zones where I can measure a significant mnemonic factor. For example, mnemonic factor 1 for the Mesoamerican. All Mesoamerica has mnemonic factor 1 and some part of South Egypt. And also we have the mnemonic factor 2, 3, and 4. Stonehenge, for example, is 3, as I mentioned, and Newgrange is 4. All these places have been studied and found the corresponding mnemonic factors. These are the physical parts of the explanation I want to say. But what are the paradigmatics? I have said that we cannot only go to the written literature. We can have also not written, but implied knowledge of the gnomon and the mnemonic factor. For example, as I mentioned in the case of Stonehenge, here we come again to Stonehenge, and we have that stone 11, stone of the height of the Triliton 1 and Triliton 2 have heights that is around 45 degrees, the elevation of the sun, making the factor, the shadow 2.4, and also 50 degrees and 2.03, that is nearly 2. And as you can see, if we take this, for example, this came for the 126, it is the 82 days. That this means it divides the year in 2 parts. If we begin with the altar rock at the beginning of the year, in the winter solstice, then we have this this division of the year. It could be a calendar, the finest, with 2 important dates, that the days when the sun is at 45 degrees. Why are they important? Because the 45 degrees is when the sun makes a shadow of a gnomon equal to the gnomon. Also, another example here, we can go to this. This is in Bersac circles that are in Romania. It's Serbia, excuse me. We are talking about circles that are putted in the plain, and has a very long time ago, they were made, and the result of our study says that we can have a very specific mnemonic algorithm for the diameters or radius of the circles of each of these circles, 5 circles. The radius of the end circle is the radius of the first one, this blue one, plus n minus 2 plus multiplied by 1.5 point twice the gnomon. a gnomon that this height of the gnomon we uses was found making the shadow of the winter solstice to coincide with the circle of this circle. This would be the height of the gnomon. Then this algorithm tells us that it is 1.5, 3, 4.5, 5.6, that is nearly 8. Then this has a very specific is the ratio with all the error we can have, but it is almost defined in this way. Then we can have again with the shadows make for the gnomon for the summer will be 3.3 meters, and with the winter 20.3 meters, and this makes us a calendar, makes a calendar for our of our site. Then we can say that in this case we can have these circles defined using the gnomon and accords to make the turns around the circle to be traced. The important thing I haven't mentioned, this is about 4,000 years before Christ is the estimated time of this, and this is very interesting thing for the history of mathematics, that some knowledge about algorithms could be found in some way. I don't say they have all the tools to have this, but it is only a relation between times of the gnomon and is 1, 2, 3, 4, 5 times the gnomon, this length. Other example here is well, let me say another example here. Let me take this for the Egypt sites along all the geography of the Nile. We can have here along this this part, we can have that, as I mentioned, in Siwa Oasis is 1/3 the Platonic Gnomonic Factor. In Meir is 1/4, 1/5 in Abydos. In Thebes and Memphis are 1/6. Nechen is 1/7, and Com Temple is 8, and Aswan is 1/9. You can ask, why is not 1.5? Well, the problem with 1.5 is that the Earth it begins the Mediterranean with above 1/2, and a surprising thing is that in the Egyptian numeration, in the Egyptian culture, all were working with fractions, unit fractions, like this mentioned here. But the other fraction that has a meaning or has its own representation is the 2/3. The 2/3 is all the other representation, and you can have that it is exactly in CYPRUS where the 2/3, where it is measured, the mnemonic Platonic factor at the south of CYPRUS is exactly this value. Then the 2/3, the one and the half is not present, but the 2/3 is present because it is in the earth, and there is a temple for Apollos Labrasius that where the place could be found. Let me. I don't know how I'm the time.
We have no problem with the time. We are okay. Just someone has to mute the microphone, please.
Okay, I can. I follow then. For the other paradigmatic aspects that we have found in these studies is the round temple of Mayapan. Professor Galindo and has studied this temple, the round temple of Mayapan, and he found that the doorways to the temple, these doorways, are not exactly in the cardinal positions, but in a different orientation, several degrees in difference with the orientation, 4 degrees around, and we uses the concept of mnemonic factor and Platonic mnemonic factor to see that in this case, if we trace a line directly in between the center of the temple and the doorway, we found very significant also values of the Platonic mnemonic factor. The 1/3, the exactly mnemonic factor 1, as I mentioned, is present in this part of the world, and also the mnemonic Platonic 0, that means the shadow of the winter solstice is 1. And also the mnemonic factor 1/2. This is important, significant values that gives that the orientation could be designed not for the cardinals, but for another purpose specifically. And also here in this picture, I have the three stela that are oriented almost north-south, and say almost because it is in the Vilchaltún, and in order that the mnemonic factor be 1, we have to turn now around 3 degrees and have this orientation. This we have found a relation in between the shadow of each of the and are related one of each other. In the summer solstice and the winter solstice, we have these factors playing a role. Let me take a look again to the picture of the Zhou Bi Suan Jing. I told you that we were going to finish this part telling more about the Tao and the way that this is known of the Chinese cosmovision. This Chinese cosmovision has to do with a flat earth that it is drawn here in a square, and a circle plane that is the sky. These two planes, one is one over the other. In these two planes, the trajectories or the motion of the sun goes in these circles that are called the cycles of the sun, and these are the seven henge, and the sun goes around, illuminating part of the earth. And in this representation, this is Shu. This is the place where the shadows of the Gnomon are measured to be 13.5 and 1.6 Shi, with a Gnomon of 8 Shi. And all these dimensions are defined from these two very measurements. And the whole is according to that dimension. The green part is the earth that the people can see from Shu. This is the size of the people can see from Shu, and the yellow part is the size of the area is illuminated by the sun. For example, here is in the equinox, or no, here is in the winter solstice. Then the pole is illuminated. In the summer solstice is illuminated the pole, and just beyond. And if we move this to here, it will be also illuminated Shu and all this part. But if we put here the sun in the winter solstice, the pole is not enough covered with the light of the sun, then it is dark. And this is the way the seasons change in this convention. The thing is that the sun is circulating over the earth in round trajectories, the henges, and this is the way it's like. But all this picture comes from this insisting in these two very important shadows. Let me say you two things that you can have at the end of this presentation. We have already take a picture of all around different parts of the world, different parts of the different epochs of the culture of mankind. And in all the places we have found several coincidences, and the Gnomon solstice's shadows have played an important role along the history of mankind. I think that it is necessary to recover this concept in order to have present in all the people for today, because all the people has to know that the sun was the main feature and has its important place in the culture. They appear specifically in several forms through the eras around foundations of mathematics. In the culture of, for example, the triangle. I just talked about the triangle, but in India, all the shadows are named as shadows of the Gnomon, and the trigonometric functions are found using the circle of the shadows of the Gnomon. You can find the cosine, the tangent, cotangent as trigonometric factors, and all are related with shadows. And also we can find several algorithms in different epochs having different kind of measurements. Then I can finish with this, remembering my professor Alfonso Mondragon, who says everything everything seems to indicate that there is a world of ideas to which humans have access as he acquires knowledge and experiments with new techniques. Thus, a given idea can appear in various parts of the world without an apparent connection and in almost simultaneous epochs. This could be my end of this idea I have presented here, and thank you for your attention. I want to thank you, the University of Sonora, Universidad de Sonora, for publication of this book and supported all the research I have done around the years to get on all these things about. I have to thank you also to all the people that have, along these years, have been, how you say, shoulder with shoulder with me, sharing knowledge and sharing studies around. Thank you very much. Thank you for this invitation of this Online Science Café, and thank you, KITION Planetarium and Observatory, for the kind reception of my work.
Dear Professor, thank you very much. It's been really very interesting presentation. I took a lot of notes and I must study them because it's a very interesting project, very interesting work, and very interesting research. If you consider, and you have considered 3 different corners of the world, we're talking about UK, Greece, and China for your 3 paradigms, and it's really interesting. And everything goes from 1700 BC to 2900 BC, if I remember well. So it's really, really interesting and intriguing to work with this and to see how it helps in the evolution of mathematics and science and the triangles, etc. It was really interesting.
Thank you very much for your comments.
Yes. I would also like to thank, I've seen in the chat, Professor Anna Lazu and her team.
Thank you too.
Thank you very much. It's been a great pleasure for us. You are also welcome to do your own presentation. You, whenever you are ready, we are pleased to have you as well. I would like to also thank all the friends from Mexico and all over the world that they joined us. And now, usually after the presentation, we give the chance to the attendees to ask some questions. Do you have any questions for Dr. Raul?
May I ask a question? it is about dating. For example, at this very slide, which we see now, there is date 2900 before Common Era. The question is this date comes from archaeological knowledge, or it is a calculation based on the data received from astronomical approach?
No, as I said, this number comes from the 2402 degrees for the obliquity of the ecliptic, and comes with an algorithm known as Lascar approach to the date. With this calculation, this gives this number for the two variables that I mentioned. The mnemonic factor has. The mnemonic factor has these two numbers, and the shadows are defined in that way. Then there are these two. Let me.
I remember there is formula which connects them. Yes.
Yes, and then it's calculated. It's not directly archaeologically defined. But some things are interesting that in the book of the Zhou Bi Suan Jing, I'm showing here the book, the portrait of the book I wrote about. It has several mentions of the beginning of the history of China. They talk about the 5 emperors and the 3 not gods. There are not gods, but magic men that are coming from the past, and this comes from that period, the 3,000 years before Christ. But the source is around 100 BC.
Mm-hmm. Okay,
it's you. Okay?
Yeah, thank you very much.
Well, perhaps if there are no questions, I would like to make a remark and, of course, thank the speaker, who is renowned for his talks, lectures for the general public, and also for the relevant books that he has written in various subjects. And I consider both his books, the recent books, I mean, concerning the Chinese cosmos, let's say, and the other, the more general one for the Gnomonic Factor, important contributions to science.
Thank you very much.
Thank you.
I just put here the picture of the book in Amazon can be found. I don't know if I can make the commercial.
Certainly.
Feel free. You can even, if you want, you can share in the chat the link.
Oh, okay. Oh, there are many people.
Yes, exactly.
We had 27 as a maximum participants.
Thank you very much.
There is a comment from our friend from England. He said, "Thank you, Professor. I will never be able to drive past Stonehenge ever again without thinking about your very interesting talk. Muchas gracias." Yes, I agree with you, Chris. And I would love to say the same, but I've never visited the place. And my son, who studies in England, he studies in Leicester, he visited the place, and he said me, he was bullying me because he visited it and he was bullying me with pictures last week. must pay visit to Stonehenge.
You can't get close to Stonehenge now. You have to, and they're even talking about building a tunnel, the roads, so that you don't go near. You don't go near
they are working
Stonehenge at all. Yeah, it'd be a shame because it's bad, and the traffic just slows right down every time you go past, and everybody's looking at the monument. It's quite spectacular. Yeah.
Mm.
I never thought it had. I thought there were a lot of theories about its importance and the significance, but I mean, you've enlightened me in such a big way. It's incredible, really. I
have presented this of a Stonehenge. I presented this in the Archaeoastronomy Society or Astronomy and Culture Society in Europe. But it was not very very welcome, because I don't know, because I'm Mexican or not from a university in England, but it was not very well received.
Why? It's really important and really interesting work. Maybe we can try to get you in touch with our affiliated Wilton astronomers. Unfortunately, they didn't connect tonight. I don't know why. But we'll get you in touch. Maybe you can lecture for them as well on Greenwich. Yeah, they will be interested, I'm sure.
Okay, thank you.
We will post this online on the YouTube channel, so we can also share it, and they can.
Mm-hmm.
We have a question from Lamberto Castro Arque. Could you answer it, please? It is in chat, Dr. Raul.
The answer?
Could you answer the question? It is in
Raúl,
chat.
tienes un prototipo para tus conferencias con niños.
Básicamente el prototipo es un gnomon cualquiera, una vara vertical puesta sobre una tabla. En realidad no se necesita más. Lo único que hay es identificar las sombras en cada uno de los lugares. I said that there is no exactly a prototype to be used there, but it is accessible with this with a straight upright cord or not cord, a straight. The Spanish belongs to okay. I was saying that gracias Lamberto, this is the prototype. Thank you very much.
Thank you. Thank you very much, Dr. Raul Perez-Enriquez. May I proceed with what we have for our next time? So all over the world, we will celebrate 16th of May as International Day of Light. And here in Cyprus, George Roulias is National Coordinator for International Day of Light for UNESCO. And George, could you say a few words?
Yes, after the international celebrations of the International Year of Light in 2015, UNESCO has come up with the International Day of Light, which is celebrated every year on May the 16th. So we try to promote, first of all, we try to inform people to avoid polluting the skies, because it's a great problem nowadays, especially in Cyprus. They have changed the street lighting from the old traditional red lamps and yellow light to white LEDs, which makes our job more difficult now. So we're trying to inform people about protecting the skies. And we also talk about the importance of light in our lives, technologies which are related to light, from medicine to physics to and other areas, but also related to cosmic light, reaches us from above. So these celebrations, we do science outreach, we do also science research related, some kind of research related to light pollution measurements, and we also do some workshops for young ages to get them involved and intrigued in the area of science in general. Due to the COVID measures, we are not sure yet. That's why we have not announced what the program for these events. But as we did with the Global Astronomy Month that is on and running in April, most of the events were done online. So for sure, we're going to have an online event on the 16th of May, same time, 8 o'clock CYPRUS time. So whatever time you log in from your local, according to your locality, at the same time, you can join us on the 16th of May, and every last Tuesday of every month, the same time, we have an Online Science Café. So please feel free to join us. It's a great honor for us. And at the end of the month, 31st of May, 8 o'clock, same time as now, UTC +3. Yeah, we're going to have the discussion, what's on the sky. So we're going to talk about important, what's on the sky. I mean, what you can observe in the sky in the summer, which celestial objects are best visible. We're going to talk about our Astro Research campaign that will end on the 23rd of May, beginning on the 26th of April, and we're going to do citizen scientists. So we're going to get some students to get involved in this research, and we are going to put them all into a beautiful session on the 31st of May. We will be more than happy you can join us as well. And don't forget that every last Tuesday of every month we hold this Online Science Café. If anyone would like to give us a talk, please feel free, send us an email. You can find the emails on the links. I posted all the links for the website in the chat, the YouTube channel, the group on Facebook. You can follow us on Instagram. We post some nice pictures. Please feel free to join us and ask, send us an email to give us a talk. We would be more than happy to have you with us. Any questions?
No.
No.
Thank you, George Trulias.
My pleasure. My pleasure. A big thank you from me and our team. And I would also like to thank Dr. Musas, who is my very good friend and mentor, if I may say. And thank him for introducing us to you that night during the presentation for the anti-Kite mechanism. It was a great pleasure to cooperate with you guys, and looking forward for further cooperation.